All right, good evening. Welcome back to Calculus 2. We are continuing talking about our rations, integrating rational functions. Right, here it is. All right, the problem I have queued up for us, and this is just going to be one little step further than we did on the previous video. So we have our 2, we're going to integrate 2x squared plus 3x plus 5, all divided by, let's see what we have here. I have an x cubed plus 3x squared minus x minus 3 dx. Again, it's an indefinite integral, so don't forget the plus c at the end. The first thing I got to do is I got to factor this top here. Now, usually when you see a factoring like this, we've got a cubic, what I would recommend is first pair, second pair. Okay. Sometimes it hits on like the 1 beat and the 3 beat, so you can kind of figure it out that way. Rarely do you get a 3 and a 1 grouping. It does happen, but in this case, I think one in the first pair, second pair is probably the way to go here. So we're going to go ahead and factor the denominator. Okay, so we're just going to write that down here. Okay, again, I'm looking at this. We've got x squared on the top, x cubed on the bottom, so it's a proper looking fraction. So we can go ahead and use our partial fraction decompositions when we get to it. So I'm going to factor out an x squared from the top. So we have x squared times x plus 3 and a minus 1 on the bottom. And we have an x plus 3 on the bottom. The minus 1 pulled out both of these signs. So we could say, okay, this is going to be x plus 3 times x squared minus 1. And this is not factored completely, so this is x plus 3, x minus 1, x plus 1. Okay, so let's go ahead and rewrite our problem. So we're just going to say, okay, we didn't really need this little bit here. We have 2x squared plus 3x plus 5 dx, all divided by, we have an x plus 3, x minus 1, x plus 1, and we're going to say, okay, well, again, setting my u to be, the bottom here, and then trying to fit the du into this piece right here, it may not work. Okay, so in this case, it definitely won't work. So it'd definitely be a lot of work to like hammer this algebraically into this form. I don't think it's going to happen. But what we're going to do now is we'll say, okay, well, let's use partial fraction decomposition. So we can say partial fraction decomposition. Okay, and we'll go ahead and we'll figure that out. So here we have 1, 2, 3 linear terms. So we could say that this 2x squared plus 3x plus 5 over this denominator is equal to an a over an x plus 3 plus a b over an x minus 1 plus a c over an x plus 1. And the first thing I'm going to do is multiply it by this whole denominator. Okay, and that was just to remind us, just to refresh us, that's going to be x plus 3, x minus 1, x plus 1. So we're just going to do x plus 3, x minus 1, x plus 1. This would be an excellent candidate to use for our cover method. And in this case, I'm going to say doing it the cover method way is left as an exercise for the reader, exercise for the watcher. So I'm going to swap the order. I'm going to put the right-hand side on the left and then do it the other way around. So we have an A. What's going to happen to my x plus 3s? Well, they're going to cancel. So I have an x minus 1, x plus 1, plus B. We have an x plus 3 times x plus 1. The x minus 1s are going to cancel. Plus C, the x plus 1s are going to cancel. So we have x plus 3, x minus 1. Okay, equals 2x squared plus 3x plus 5. Okay, so let me go ahead. I'm going to pause this for a moment. I'm going to multiply all of this stuff out, but I don't think you need to watch me do that. So I'm going to pause real quick and do that. Okay, and we're back. Okay, there's a little bit of algebra. Okay, a lot of algebra here. So I've multiplied these things through. So again, my a is the x plus 3 is canceled. So I just have ax a times x minus 1, x plus 1, which leaves me as a times x squared minus 1. And I just went through and multiplied all these pieces out and then multiplied them through by the b so we can go ahead and figure out what's going to happen here. Okay, and that's all that happened. So what I'm going to do is I'm going to go ahead and say, well, we're going to take all of our x squareds, which is going to be this one, and this one, and this one, and this one. Okay, and then we're going to say, okay, we need our use the blue. Let's use pig for our rational term or linear term. So we have the pigs being just the x terms. Okay. And then let's see, what color do I have left here? We'll say we have green. I didn't use green yet. So we have green to have our constant terms. So we're going to be able to set up our constant terms. Okay. I'm sorry. Let's get it right here. Don't forget the signs. Okay. So here's what we're going to do. So we're going to go ahead and see what we have here. Fortunately, through the magic of editing and the magic of doing this problem earlier, we're collecting all of our x squared terms. So we have an a plus b plus c is equal to 2. Okay. Collecting all of our linear terms, we have 4b plus 2c is equal to 3. Okay. And then finally, with my constant terms, we have negative a plus 3b minus 3c is equal to 5. Right? So 3 equations, 3 unknowns. Again, this would be an excellent candidate to do the cover method, but I'm going to do it this way for the sake of showing people who are like, I don't like the shortcut yet. So we can go ahead and sort this out without the shortcut and actually do the problem. It's really not that bad. So what I'm going to do is I'm going to note that the way that I do this is that I try to eliminate all the A's first, well, except for the first one, and then eliminate the B's, and then I eliminate, so we only have one C left. And that's pretty much how I work this thing down. So I just kind of work this system down as such. Okay. Later on, your calculators will do this for your calculator. When you get to be a junior, you have your TA 83, 84, that'll do that for you. So right now, I'm just going to add equation 1 and equation 3 together, and then we're going to replace equation 3 and put it back into equation 3. So we have a plus negative a. So I'm just going to write down a plus b plus c is equal to 2. We have 4b plus 2c is equal to 3. And when I add these together, we have 0 a's. I have b plus 3b, which is going to give me 4b. We have c minus 3c, which is minus 2c's. And then we have 2 plus 5 is equal to 7. I believe that's what I have right next to the spot there. Okay. Let's see if we have, before I'm looking for the answer that I came up with. There we go. All right, so there we go. So what I'm going to do now is I'm going to add equation 2 and my new and improved equation 3 together. So we have 2 plus 3, and insert this back into equation number 3. Okay, so I'm going to keep the row 1 by itself. So we have a plus b plus c is equal to 2. Yep. We have 4b plus 2c is equal to 3. You don't have to keep all of these. You don't have to write down everything, all of these things all the time. You're free to like go ahead and change and write down only what you need. Here we're going to have 4b plus 4b is going to be equal to 8b. The 2c minus 2c was 0, and then we have 3 plus 7, which is going to give me 10. Well, at that point, I think I could solve for b. So we have b is equal to 10 over 8, better known as 2 times 5 over 2 times 4, 5/4. Okay, so we have that. Now we're going to take this result and we're going to plug it into my next equation up. So we have 4 times b, 5 over 4, plus 2c must be equal to 3. Just plugging it back into the next equation up. Well, 4 times 5/4, that's really easy. So we have 5 plus 2c is equal to 3. Subtract 5 from both sides. We have 2c is equal to negative 2. C must be equal to negative 1. Okay. Now that I know my a and my b, we're going to be able to say we don't know a yet. Rather. We have a plus b, which is 5/4, plus c, so minus 1 is equal to 2. Now I just got that off of the first equation that I kind of sorted out here. Okay, it's this equation up here. And then we have to go ahead and do this arithmetic. We have 5/4 minus 1, 4/4. So we have a plus 1/4 is equal to 2. Well, if we have $2, that's going to be 8/4, right? 8/4 minus 1/4 is going to give me 7/4. So we have 7/4 left here. So a is equal to 7/4, right? So we can go all the way back up to where we started this thing with my partial fractions and then say, we have a over x plus 3. A is 7/4. I'll show you something when I get to this spot for it. So we still have to integrate. Okay, we're not done yet. We'll try and integrate. So I have 7/4 over x plus 3. Okay. And then let's see, what else do we have? We have plus 5/4 over x minus 1. And then we have minus 1 over x plus 1. Okay. Now, when I took this class, this really bothered me because I didn't like a fraction on top of a fraction. And I thought it got rid of my pattern recognition for saying, oh, integrate 1 over u du, that's natural log u. So what I would do is say, well, this is a constant. And I would put this thing in front. So I would say, okay, we're going to integrate 7/4 times 1 over x plus 3 plus 5/4 times 1 over x minus 1 minus 1 times 1 over x plus 1. And I'm still integrating all of these pieces with respect to x, okay? And we just have to integrate these little pieces here. So in each of these integrals, this 7/4 slides in the integrals. So we have 7/4 times the integral of 1 over x plus 3, which is just going to be the natural log of x plus 3, plus 5/4, natural log, absolute value, x minus 1, plus, or I'm sorry, not plus, minus 1, okay, times the natural log of the absolute value, x plus 1, don't forget our plus c, but that would be my answer for this monstrosity of a problem, okay? So it's an indefinite integral, don't forget your plus c's. These are all linear terms. If x was like a negative 10 or something like that, we would definitely need our absolute values, so don't forget those. But I did it this way. I did it with the equating coefficients method. You are more than welcome to try this as with the cover method to see if you can't be a little bit better with it, and that's fine. And that's pretty much what we're going to end our video for us today, okay? So we're going to do another one next time, and it's going to be a definite integral, and we'll see how it goes with that, okay? Thank you very much for watching. I'll see you in the next video, and take care.